Hello, ladies and gentlemen, and welcome to Mr. Saucedo's YouTube videos. Today we're going to be looking at balancing redox equations using oxidation numbers. So hopefully you watched the video on oxidation numbers already, but here is a very simple way of using oxidation numbers to balance a redox equation. So the first thing you need to look at is you need to assign all of the oxidation numbers for every single element in the reaction, identify the elements that are being oxidized or reduced, and use a line to connect them. And then what we want to do is we want to increase or decrease the oxidation numbers so that they are equal but opposite, right? So if we have a +3 change overall, that means that we need a -3 change in order to balance it. So what we are going to do is, just like when we were balancing equations before, place the appropriate coefficients until we have everything as the same. Then you want to check your equation and make sure it's balanced for both atoms and charge. So you want to make sure that all your atoms are equal on both sides, but also that your charge is overall the same on both sides of the equation. So here is the way that we are going to do that. So we have which elements are being oxidized and which are being reduced. Balance the equation using the oxidation number method. All right, so we've got iron 3 oxide, we've got carbon monoxide, and we're making iron metal and carbon dioxide. So let's assign our numbers. I know this is a -2 because by definition it is, so that's a -6. That means this has to be a +3. Here, -2, +2, nice and easy. This is a element in its standard state, so it's 0. And then I have, again, a -2. That means that this is going to be a -4, which means that has to be a +4. Now, what I want to look at here is notice that my oxygens are the same no matter what, -2, -2, -2. So there's nothing changing there. But what is changing are the carbons going from +2 to +4 and the irons going from +3 to 0. So what I'll do is I'll connect my irons and say, okay, that is going to be a -3 change that I want here. This is going to be a +2 change, right? So I lost 3 here, whereas I gained 2 here. Now I need them to be the same number. And so the only way to do that is to make them all 6. So that means that I would want this to be a -6 overall, and I would want this to be a +3 overall. So how can I go about doing that? Well, before I do any of this, let's just answer the actual question, which is being oxidized or reduced. So iron is being reduced in this situation, and then carbon is being oxidized in this situation, right? Again, just by definition of reduction and oxidation. Okay, so how would I actually go about balancing this? So again, I want to make sure that I multiply everything by the appropriate numbers here, but I want to make sure that I'm keeping track of not just my charges, that I'm keeping track of my elements also. So for here, it's kind of easy, right? So I would need to do 3s here. So I would need a 3 here and a 3 here to get these to be the same. And notice I still have my 3 carbons and I have my 3 carbons. Now here's where it gets a little tricky, because if I multiplied both of these by 2, I would now have 2 on this side and I would have 4 on that side. So I really only need a 2 here in order to have 2 irons here. And now I have my complete balanced equation. So that's one way of using the oxidation number method in order to balance equations. Now, it's simple, but it's not exactly the most useful. And the reason why is because very rarely are you going to have equations like this. Normally, they're in aqueous solutions. And so since they're in aqueous solutions, you're not just going to have gases and solids and stuff. You're actually going to have water and acid and base and stuff that are going to be involved, all right? But for now, that's all you need to know. So if you have any questions, please let me know.